The landscape of artificial intelligence conferences has shifted fundamentally in recent years. We are no longer just talking about model accuracy or theoretical novelty. We are talking about the infrastructure that validates that work. For years, the bottleneck in scaling AI research has been the human capacity to review it. Every major conference is facing an exponential growth in submissions that traditional peer review simply cannot handle. The result is noise. Scores become arbitrary. High-quality work gets buried under volume. This is where the conversation for ICML 2026 becomes critical. It is not about a single algorithm. It is about the architecture of the review process itself. We need to analyze this through the lens of MLOps scalability, because the review pipeline is the deployment gate for academic discovery. If the gate is clogged, the production pipeline stops. Consider the first major architectural shift, the introduction of self-rankings. For decades, the assumption was that authors would not know their own work best. But recent findings suggest that author-assisted mechanisms can actually improve quality assessment. The idea is to treat the submission like a product launch where the creator provides a confidence score. This uses game-theoretic incentives to elicit truthful quality estimates. In a production environment, this is similar to how a developer rates their own pull request before handing it off. It forces a moment of reflection before the external review begins. By combining these self-rankings with traditional peer review scores, the system can predict citation impact more effectively than either method alone. This reduces the cognitive load on the committee. It allows the human reviewers to focus on the papers that truly need scrutiny rather than triaging every single submission from scratch. This is a scalability feature, not just a convenience. It optimizes the signal-to-noise ratio before the heavy lifting begins. Now consider the second layer of this new infrastructure, which addresses the integrity of the review itself. There is a growing consensus that standard review scores are becoming noisy and arbitrary due to the volume. One specific response to this is the implementation of strict rejection policies for papers where reviewers are found to have used LLMs to generate reviews. This signals a shift towards enforcing human-only review integrity. It is an arms race. As generative models improve, the temptation to automate the review process increases. The conference is moving towards active detection and punitive measures. Anecdotal reports suggest that prompt injection or LLM-generated content is becoming a common feature in review batches. The system is now designed to detect this. It is not enough to just ban the practice. The architecture must verify it. This requires automated verification becoming a standard gatekeeping mechanism for acceptance. Without this, the review system collapses under the weight of synthetic noise. We are seeing a move towards enforcing human-only review integrity, which ensures that the feedback loop remains grounded in genuine human expertise. This is crucial for maintaining trust in the field. The third component of this architecture is the tracking and consistency layer. We are seeing a significant trend of review recycling, where authors or reviewers report papers being assigned that were previously reviewed in other conferences. This indicates potential gaps in the double-blind or conflict of interest tracking systems. To combat this, the conference is moving towards dynamic, consistency-ensured datasets and automated tracking tools. Think of this as version control for the peer review process. Tools like Paper Copilot are proposed to archive and track review evolution. They monitor the evolution of peer review quality and detect anomalies in real time. This allows the system to identify if a review is a duplicate or if a reviewer is behaving inconsistently across different submissions. It turns the review process into a data stream that can be audited. This is essential for MLOps scalability because it means the system can learn from its own mistakes. It can flag patterns that suggest fatigue or bias. It creates a feedback loop where the review mechanism improves over time, just like a model that is fine-tuned on new data. When you look at these three components together, you see a complete system redesign. The self-rankings handle the initial triage. The LLM detection handles the integrity check. The tracking system handles the consistency and history. This is not just about making the conference run faster. It is about making the research more robust. In production machine learning, you do not deploy code that has not been tested. You do not deploy models that have not been validated. By treating the review process with the same rigor as the code itself, we ensure that what gets published is actually ready for the real world. The current research collectively highlights a critical strain on AI conference peer review systems driven by exponential submission growth. But these new mechanisms offer a path forward. They leverage author incentives to elicit truthful quality estimates. They offer a game-theoretic complement to the current system. However, there are still challenges. Significant knowledge gaps remain regarding the specific implementation and outcomes of these new systems in the immediate future. While tools like Paper Copilot are proposed to archive and track review evolution, the lack of specific data prevents a definitive analysis of how these new consensus-driven strategies will be applied in every context. The field agrees on the need for innovation to handle scaling submissions, but the practical efficacy of these new mechanisms in the immediate future of ICML 2026 remains unverified by the available text. We are moving towards future AI conferences that will likely require explicit declarations of AI tool usage in the review process. This is a standard gatekeeping mechanism for acceptance. The community sentiment is shifting from concern over LLM usage to active detection and punitive measures. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.